This web quest is for Elementary Ed 4300, Methods in Teaching Science. Science Matters, Chapters 3, 4, and 5. Chapter 3 is about electricity and magnetism. Maxwell, James Clerk Maxwell, who was a Scottish physicist, summarized the laws or equations of electromagnetism in 1861. Now, a lot of scientific discovery had been made about electricity and magnetism before Maxwell. However, he unified these, and this is the major contribution he made, as well as adding to what previous scientists had discovered. Maxwell's equations are these four statements. First of all, electricity and magnetism are two aspects of the same force. Our bodies, all of the atoms, and even the earth is a magnetic field. And this was something that Maxwell unified in that there's electricity and magnetism, and they are two aspects of this same force. Secondly, there are no isolated magnetic poles. When you have something even as small as an atom, you have the poles, the north and south poles, and when you have something as large as the earth, you have a north and south pole. You can't isolate the poles. You can't cut a magnet, for example, in half and have a south only pole and a north pole. It will realign to where there's a north and south pole in any magnetic material. Third, moving electric charges creates magnetic fields. And really, this is where the electricity and magnetism are unified, in that electrical charges also create magnetic fields. And this, as mentioned in our textbook, was discovered by a science professor whenever he would turn on an electrical generator, would notice that the needle in a compass would move a little bit, and started noticing the effects that electricity have on magnetic fields. And then fourth, Maxwell states that magnetic effects can accelerate electrical charges. So magnetic material can change the electrical current going through a circuit, for example, or a generator. And this is where we really, from Maxwell's equations, we have all of the electrical devices we have today. He would have had no idea in 1861 the impact he had on our modern society. These four equations together form a complete description of the production of interrelation of electricity and magnetic fields. Again, here are the four statements that were made by Maxwell and his four equations. We've pretty much discussed them on the previous slide, but know that this is how you would see them in a science textbook. First, electric field diverges from electric charge. So the field diverges from an electric charge. Second, there are no isolated magnetic poles, like we mentioned before. Electric fields are produced by changing magnetic fields. So again, this reduces his equation down to the very idea that the fields are produced by changing magnetic fields. And this has everything to do with the electron in an atom, as we discussed with when we talked about electricity, this is that magnetic field change in the atoms. And fourth, circulating magnetic fields are produced by changing electric fields and by electric currents. So we can also produce circulating magnetic fields by changing the electric fields. So they both affect each other, basically, is what Maxwell's saying, is electricity affects magnetism and magnetism affects electricity. I just wanted you to see a shirt that is donned by a lot of physicists. Um, they like to make maybe fun kind of Maxwell's equations and how important they are in understanding the forces of electromagnetism, light, and basically um, most of what we experience here on Earth. Electrical charges are carried by subatomic particles. And so we'll learn a little bit more about the building blocks of atoms in the next chapter. But the atom's massive central nucleus is a positively charged cluster of particles, while the lighter negatively charged electrons orbit the nucleus. So we'll look at the structure of an atom, but just know that this is where you've got the magnetism and electrical charge that work together in keeping the atom together. So we've got these positively charged nucleus that attracts the negatively charged electrons that orbit the nucleus. Protons are positively charged where neutrons are not charged, and so that's what the nucleus is made of in a atom. The French physicist Charles Coulomb first wrote down the laws of electric charge, and he put like charges repel each other, unlike charges attract each other. Between any two charged objects is a force proportional to the size of the two charges, divided by the square of the distance between them. So again, here you can see this is kind of like what they had found with Newton's laws. And as far as there's a formula, there's an equation that you can actually measure the force of electricity. And so again, this is where Maxwell put these equations, unified them, but this was earlier. Charles Coulomb in France found this as well. Electricity, electrostatic attraction keeps negative electrons in orbit around the positive nucleus of an atom. And we'll do some hands-on experiments with this in class. Typically, a motor that converts electricity into magnetic fields incorporates multiple sets of permanent magnets and several synchronized electromagnets. Now, you should know permanent magnets are magnetic on their own, magnetic materials such as what we're used to sticking on our fridge or clipping on your name tag. Electromagnets, however, are created through an electrical current, and you can actually turn them on or off. And most of the electrical appliances that we use today have both permanent magnets and electromagnets. We'll do some investigations with these in class. Electrical current in generators flow in an alternate direction. So they'll go back and forth, they'll flow alternating. And that's why they're called AC current. So if you look at a lot of your devices, electronic devices or small appliances at home will have AC. Some devices can be AC or DC. That's if they can be battery operated or electrically, plugged into a outlet. But then we have also things that are just battery operated, and this would be batteries flow in one direction, and that's called DC. And so that kind of explains to you the difference between the currents in a battery, which is a chemical reaction taking place and it just continuously flows in one direction, and where we have generators that are alternate direction or AC. Now, electromagnetic radio waves were also discovered as a result of Maxwell's work, and some research had done before, but he unified this again with the electrical current and the magnetic fields. All electromagnetic waves can be described by speed, wavelength, and frequency. And these are the measurements used in the equations with electromagnetic waves. Also, when you hear about radio waves, they're also measured by speed, wavelength, and frequency. Wavelength is the measure by the distance between the adjacent crests in the series of crests. So this is the height where the wave of the electromagnetic wave is cresting and peaking, and this would be the distance between the two crests. Speed is measured by the movement of the crests. So this is how quickly the movement is. Frequency is the measure of how many crests pass at a given point in a second. So this is how closely together the crests and troughs are. So when we hear the word hertz, 1 hertz is 1 crest per second in that given space. Higher frequency is also higher energy. So the more hertz, or the more crests and troughs you have at a given point, the more energy is needed to create this. And that's where we have the different spectrum of energy and how we go from radioactive waves to the less energetic radio waves. And we'll do an investigation on this in class. So here are some questions I want you to come prepared for to discuss. Question number 1, which force is stronger, gravity or magnetism? Number 2, how does an object like a balloon or plastic comb obtain an electrical charge? We're going to have you draw and describe how that works. Number 3, what energy is used to transfer information on a cell phone? And number 4, how is light an electromagnetic wave? So you're going to look at these 4 questions. We're going to do some discussion, and we're also going to do some things with chapters 4 and 5. But for today, I just want you to listen to this web quest on chapter 3. All right, we'll see you in class.